Moshe okay, I'll start from the beginning. Thank you everybody for joining today. I do apologize for this technicality and misunderstanding. Today we'll be joined by Moshe Safran. Moshe is our CEO of our US-based activities, and he'll be presenting most of the interesting things today. What I just try to do, and I'll do it again very shortly, is presenting RSIP vision very quickly, just so you'll know who is talking and what kind of experience we're bringing to the table today when we're going to talk about these issues. So basically, computer vision, deep learning solutions, and AI, mainly developing this kind of solutions and enhanced based AI solutions for a variety of vendors and customers, most of them in the States. We have a lot of activity going on in the last 5 or 6 years in the automotive industry, but just as well, we're dealing with different verticals in the market as well. It could be medical devices, could be industrial inspection, and others. Our team contains around 60 engineers divided between our offices. We have 2 main R&D centers in Israel, one in Tel Aviv and one in Jerusalem. And we have 2 offices in the States, one on the West Coast in San Jose, and we have one in the East Coast in Boston. Okay, so in the automotive industry, we have a lot going on, like I said, in a variety of applications, dealing with different kind of sensors. So you can see a handful of examples on the slide. So you can see we've been dealing with LiDAR projects. It could be artifact correction, it could be data cleaning, it could be building applications on top of the data received from the LiDAR. We can detect a variety of different kind of applications. Could be looking inside the car, it could be outside, done different kind of projects. Of course, sensor fusion. So we all know today that most of the application will use more than one sensor because of each sensor's limitations. So we have a lot of experience in that as well. In cabinet applications in the last year and a half, we've done quite a few in these. And of course, perception solutions, looking outside of a car. We've been doing that for quite a while now. Like I said, we have, besides the automotive industry, we have a lot going in the market field as well, like medical devices, industrial inspection. We have an example here for fruit grading. So we have a lot going on in, I would say, innovative agriculture technologies as well. And why is it related for today's webinar? It is related because the know-how and the experience of our team in the last almost 25 years is relevant, and product you actually can take it to another, even if it's not in the same exact field. So for example, you can see on the lower left an example for a C-arm where we've done a lot of application fusion and sensor fusion applications around that, and we took all of that knowledge when we suddenly need to fuse an automotive application, for example, with LiDAR and RGB cameras or something like that. And just the same, on the left side, you can see a 3D reconstruction of a heart. So in a way, it's similar to what we do with point clouds, because you need to do on a point cloud data, you need to understand the perception and build some kind of 3D model. And we took that knowledge to the other project in the automotive industry, and that gave us a lot of understanding, and it was a key factor in successfully developing these kind of capabilities. So just important for you to know that. And the last thing I would say about us is that we're involved in a lot of other activities besides developing solutions for our customers and consulting. We have the Computer Vision News magazine. It's a monthly magazine presenting most of the cutting-edge technologies each month. Deep interview with innovative companies, and in general, what's computer vision in the world. And that's something that I'm interviewing, presenting, sending updates, and a lot more. So I hope that was pretty quick, and I hope it's what you heard me. And I'm going to pass the microphone to Moshe, and I think he's going now to talk about the most important thing, and that's the reason you joined us today, and that's giving you some of our insights regarding how to manage successfully these kind of projects. We deal with it on a daily basis, and we'll be happy to share some of our insights. Moshe?
Hi everybody, it's Moshe Shmulik. Do you hear me well?
Yes, I can hear you.
Okay, let's keep our fingers crossed. So before I get started, just a little self-plug. I'm going to be talking actually about LiDAR data cleaning today, this evening, in the Sensor Fusion meetup in Sunnyvale. So if any of you are interested and are in the area, it'd be great to see you there. I think they've got pizza and beers there as well. But I'll be talking about computer vision and physics-based algorithms for LiDAR data cleaning. So so today our agenda for the webinar is developing AI solutions, basically project management tips, specifically from the point of view of our automotive-related projects. So let's get started. Yeah, so in the next slide we can see the first tip that we always like to give, and this is relevant for automotive-related projects and for other industries. This has always been true, which is that we're in a deep learning revolution in computer vision. There's a wave of startups. Obviously, in autonomous driving, this is what's made the whole field possible, but also in the sort of automotive adjacent applications Shmulik mentioned before, such as in-cabin computer vision, and even in the more low-level sort of data cleaning applications, we are also seeing lots of uses for AI and lots of cool new functionalities. So 80 to 90% of the papers that are published do come from the deep learning area, etc. So yeah. So this is well known to everybody. It's not at all new, and the old ways of managing projects actually were never all that good for sort of more algorithm research type of applications, because things there are more complicated. You need to be more agile about them. And they don't work for deep learning all that well either. Even though some people say, yeah, AI, it's all engineering. You just got your data pipeline and you're reiterating the same thing over and over again and just turning into a big engineering system. It's not really true. In most cases, that kind of a brute force approach will not help. And you need to be more creative about the way you manage these development efforts as well to really do novel R&D. And to get quick, effective solutions and do creative work. So in the next slide, so we're going to go through 12 tips from these projects' point of view. And what we always like to say is review 100 images. So even if you've got tens of thousands or even more images in your database, that's not a replacement for looking at representative examples yourselves. This should not only be done by annotators or by QA type of people, but it needs to be done by the R&D people and by the team leaders who are leading the effort to understand the failure modes of the system and to come up with new ideas. And this is still correct. This is still accurate today, even in the age of huge data sets in AI. There's still no replacement for using your own eyes and for understanding what you're up against yourself with your own eyes and your own mind. So and since we're all human, I mean the number is still 100 images. This is just an example from distracted driver detection. So different genders, different skin tone, different race, different poses, different ways people hold their head. This is obvious sort of to anybody who thinks about this problem themselves, but it's not always obvious to people who are trying to implement an AI solution. They think they're just going to throw a ton of data at the computer and it's going to work, and that's not the way things work. Now, in the next slide, along with this tip for viewing 100 images, you still also need to review 100,000 images, or at least tens of thousands of images. So along with your higher level people in project management and in R&D, really understanding the specific classes of data and the sort of the high level understanding of the types of challenges you're up against and generating new ideas, you also need to create a whole operation for quality control, for data curation. And what we have found is a proximity of annotation team to algorithm team. So we have found that so when we need a huge amount of work to do, there's no replacement for outsourcing it and sending it outside. Sometimes crowdsourcing, sometimes we're working with data annotation companies who have huge teams, but there's still no replacement for something in between, which means that you may have an outside annotation team doing most of the grunt work, so to speak, but it's still very useful to have an in-house annotation team who are sitting next to the R&D and even having some overlap between those teams. So you can have somebody whose role is both an annotation team leader in sort of making sense of the data, and is also actually implementing hands-on the scripts and the solutions for the data management pipeline. So you really need these two parts of the team to talk to each other and have sort of intermediate type of roles in your team. So tip number 2, a multidisciplinary team. So besides annotators, besides domain knowledge experts, and besides what has become your standard machine learning engineers, you still need several sources of ideas at each step. For data creating, this is obvious. You need to understand the physics and the signal processing aspects of the system in order to come up with a correct solution. And this requires teamwork. This is still true today. This is not the need for people and for multidisciplinary skills is not dead in any means, even in computer vision. Yeah, so this is the example from LiDAR data cleaning. So you need real-time embedded expertise to understand how the data is being processed and how what you need to do to get the required throughput. You need to understand the physical aspects such as multipath interference, phase hopping, other artifacts. You need classical computer vision algorithms to quickly clean the data. You can't do everything with a neural network. And then at the higher levels of the system, you use AI, both for image enhancement and also for obviously segmentation, tracking, perception, etc. Okay, tip number 3, deep learning is not just a black box. I think I've sort of said that already a few times. So you need to reiterate and you need to look inside the black box. You need to understand the failure modes. I don't really have much more to add on this regard. So let's go to the next example. Yeah, okay, so this is an interesting example, actually. So everybody needs to do forward collision detection. This can be in a variety of types of environments, a variety of types of inputs. You need to do it, as far close to the edge as you can, so limiting compute. And you want to do solutions such as finding your direction and only detecting forward collisions and ignoring sideways collision. Applying your AI and applying your limited computer resources only to the region of interest you need. Yeah, tip number 4, always deliver from POC to validation. So this is sort of a well-known credo in the agile software development community. It's sort of already a very well-established way to work in software in general. And we believe that the same should be done for R&D of algorithms. So even though, there's risk involved and you don't know which technology is going to work best when you start out, it's still very important to get your feedback from the real world and from the outside environment. And the way to do this is deliver something in relatively short time cycles, estimate the delta of the effort, and estimate what kind of results you can expect at the next iteration. And we try to deliver something every week. Now, when you try to deliver something every week, this does not necessarily mean a new version of the software every week, but it means some meaningful results. It can be a working software version or a new release candidate. It can be a stub model. It can be a refactoring report. It could be even just a literary review. But if you have these time-boxed efforts of a week or 2 weeks, it makes the whole project run more efficiently, and it makes you able to adapt yourself to what you discover much more quickly. When deep learning fails, so you don't jump to conclusions like more data, more complex algorithms, new method that someone read about. It's very easy to fall in love with all the great, cool new papers that are coming out on a monthly basis these days in deep learning. And there's always new architectures that the engineers would love to try out. And there are always these, really cool technologies that are interesting to read about. It's not always what you want to do. Similarly, just getting more and more data and hoping to get these slow incremental improvements is not always going to do the trick. And you still, really, there's no replacement for failure analysis, code validity, for having experienced people look at the results visually and use their heads. This is just a simple example from pedestrian detection. So the system can work during the day. The accuracy is going to drop at nighttime unless you specifically train for this, unless you add the proper augmentations, collect the proper data, play with the brightness, the contrast, etc. There are many difficult corner cases here that you need to figure out how to put it into your data set in the right percentages and the right balancing, and not to miss any type of corner case. Okay, false positives can fuel your product. This is true in medical, and this is true in AI and in automotive. And you need to be aware and fight back. You need to understand what the false positives are coming from, and adapt your data collection efforts as well as your R&D efforts accordingly. Yeah, so specifications change, and you need to change the algorithms. The agile people love to talk about this, and this is true for computer vision. This is true for the automotive space and the long tail of the automotive space, in which we're finding sort of our watering holes. And you should try to plan agile infrastructure instead ahead in terms of the tools that the team are using, and just the culture in the R&D teams to be used to doing this, and make sure that people are not scared of this, and realize that this is part of it's part of the course. It's a normal thing. And the success criteria sometimes can also adapt. So once you have a changing requirement, your success criteria may change as well. And of course, you need to understand what the business case is for minimizing false positives versus minimizing false negatives. Are we more interested in never missing a detection if it's a pedestrian, or if this is just an example from an industrial application, perhaps we're more interested in getting yield, or we're constrained by some minimal yield we need to generate, so then we can't have too many misses. We need to understand and define them early, and understand the correct way to define them. So for automotive, this is probably less salient, but in many cases, human observers do not agree with each other, and you need to take this into account when you define your appropriate success criteria. Of course, a lot of people in automotive are hoping that success criteria will be that the system is no worse or is even better than human. Perhaps that's not going to be enough. Yeah, this is another collision detection example. So first of all, obviously the price of missing a false positive is fatal, and also there are many different environments, and the solution might be, or the emphasis on the R&D effort might be completely different depending on where you're going to be deployed to. Highway versus crowded urban environment is a very different type of challenge. effort in proportion to data set size. So if you think you don't have enough data, then don't invest your R&D efforts yet. You should make an effort that's proportional to the amount of data you have. If you just have a little bit, do a quick proof of concept. Even if you think you can make it better now with the data you have, sometimes if you work too hard before you have enough data, you're going to run the risk of overfitting, and the resources should be invested in the data collection operation. What do you do if you're running behind schedule? So first of all, you need to understand why the team is running behind schedule. To know who the people involved are. Is it a problem of programming skills, of experience in the proper field of AI? Is the ability to converge? Sometimes the team is trying, shooting in every direction and is trying too many things at once to solve the problem in too many different ways, and they're not going to be able to converge in time, even if one of the methods they're trying could be good enough at this stage. And there's always, the danger of feature creep, of trying to do too much at once. Sometimes it makes sense also to separate the project into two tracks. You have a fast-paced track, that's the development track, that you're delivering something useful quickly, and they got to be very focused and really, cut out all the fat from the effort, and you can still have another component of the team doing research so that you're still developing something that's going to have added value when the day is done. Tip number 9, algorithmic design documents. So you need to worry about this from the get-go. You should start understanding what documentation is going to be required from the beginning, and keep it concise and relevant and updated, which means if you do too much, it's never going to be up to date. But if you don't do what you really need to do, then that's going to give you a very big technological debt, and that can get you in trouble later on. So it's sort of a delicate decision to make at times. Python and MATLAB to C++. In many cases, in AI and deep learning, this has become quite straightforward. But once you're adding like pre-processing and post-processing, etc., this still can become an issue of making the code consistent. And it still makes sense to take this into account at an early stage, get quickly to the target platform in parallel, even to the algorithm development, solve whatever technical integration issues you have early on. Tip number 11. So the project manager has to understand what family of algorithm should be selected based on the amount of data, how much time you have, how scalable do you need the algorithm to be, how it's going to be validated, and change management. And all of this is going to inform the technical decision of what solution avenue to explore. It's not one size fits all. Okay, and tip number 12. So in the hardcore, autonomous driving world, this is becoming less and less relevant to use a variety of tools, because really most aspects of the problem are turning into a deep learning neural network type of operation. But even there, it's not 100% so. So, if you're detecting lane markings, then maybe you have a neural network that's detecting the markings in the image and, doing a segmentation type of task, but you're still fitting that to a model of the road afterwards, and you're still comparing it maybe to a known model of the road. And in the more long tail type of applications, whether it's in-car or data cleaning, etc., this is still very much true. You need a wide variety of skill sets within your team in order to stay competitive and in order to deliver the appropriate solution to each situation. Okay, and there are still cases where deep learning is inferior to non-neural network computer vision. So some of the examples here from industrial, exact measurements, pre and post processing, 3D reconstruction, model-based reconstruction, which is still relevant in the medical field. We found that in automotive, this also may be the case. I think we got an example, specific example on the next slide. Yeah, so this is our slogan. Sometimes you need a hammer or a huge sledgehammer, and that's what all the big players in automotive are doing all day. They're doing their millions of miles and simulating their billions of miles or whatever. But in many cases, what you need is a screwdriver. And if you have a hammer, you're just going to hammer yourself against the wall, so to speak. So this we've found that's true for what we've been doing and trying to do in the automotive market. Yep, there it is. Even the biggest hammer cannot replace a screwdriver. So in the next slide, we probably have a specific example. Yeah, that's my toolbox. Yeah. I wish I had that bigger hammer. Yeah, so this is a recent fun and interesting example that we've come across. Segmentation of sparse long-range LiDAR data. And for this type of data, it's not obviously not in a crowded urban environment or even a highway environment. It's in a different type of environment. It's still LiDAR. You still need to do object detection, but the data looks like this. There are very, very few points in the field. And because this is a pretty early stage of the R&D for the system, there's very little data that's similar to this data to work with. So you just can't do deep learning. You can't throw this at some neural network, and you need to go back to classical clustering algorithms and build some pre-processing and some logic around that. And that proved to be the right way of getting any result at all for this object detection task and creating an effective proof of concept that served our client. So to summarize, as managers, we always try to look at things through the prism of success. This could be success at different time scales: short time, medium time, long time. But that's the project management perspective. Therefore, we're always interested in the validation process at every stage of the way. And we find that we believe quite strongly that it's not a good idea to separate project management and program management from R&D. So many companies, they have a program manager role, a project manager role, coming from a non-technical or semi-technical background, and they're sort of the account manager for the client. And then you have the R&D who are the how, who are actually implementing these things and figuring out how to make it work. We believe that these two aspects cannot be separated, because the project manager needs to have deep understanding of the algorithms that are being used in order to choose the right solution, in order to create the correct expectations for the project management aspects. And therefore, we do not really separate these roles in our company. And that's our recommendation for our fellow agile or trying to be agile AI companies in automotive, in the long tail of the automotive space and market, and for AI in general. So thank you. I hope this was interesting to you guys. Shmulik, I hope you were able to hear me okay.
Yes, definitely. Thank you very much, Moshe. It was extremely interesting, and I hope everybody found it very useful as well. So we still have a few more minutes. If anybody would like to send us a question, we'll have a short Q&A right now. So let's take a few seconds and see what people are asking here. We can share that. Just a second. Okay, so I can see the first question is from Mark. He's asking, what's the difference between managing a a short project, a 3-month one, towards a longer project? He writes 9 to 12 months.
Mm-hmm. Yeah, so that's a great question. So if a longer project, you mean 9 to 12 months, so multiple quarters. So maybe a short project is 1 quarter or 3 or 4 months or something like that. So obviously, if there are 2 types of short projects. The first one is a short self-contained project. So the task is well defined. It's an easy task, which is why it's a short project. And then sometimes there's not much to manage. Those are sort of the easy short projects, the ones that are actually a sort of a relatively small task that's going immediately to production. And then there's the second kind of short project, and those are what people call, prototypes, proof of concept projects, research projects. So, a company wants to try something new, or they have a new product they really want to develop, but they need to prove that this is going to work. And those are the most challenging ones. They can be more challenging than the long-term projects because you need to surgically define the scope of your proof of concept, and you need to be in constant contact with the stakeholders, with your potential users, or the potential internal customers of your immediate client. You need to understand how this is potentially going to be used in the organization, and focus your efforts with laser precision to demonstrate what it is you want to demonstrate. That's going to be most effective in moving new developments along within the client organization. Longer term projects, you still have a lot of that. You still need to focus the R&D effort, but here you get to actually build something that's useful in terms of the final system at every stage of the way. So you break the project into chunks, and you break it up into smaller tasks, and you deliver a concrete delivery, but your delivery doesn't have to be focused on understanding the problem, unlike the short POC type projects. The point of the delivery is less to understand the problem and to show how this can be used, but it's actually to build various components of the functionality and show that each component of the system is working.
Okay, great. Thank you, Mark. I hope this is useful for you. I have another question from Tom. How much data should you have to start an AI project?
Everybody always wants to ask that question. So these days, a lot less than in the past. So if you have 5 samples, then don't do AI, like the long range LiDAR one I showed you before. Do something else, or invest your efforts in your data collection and your data curation. But for segmentation tasks, if you have 100 examples, within those examples, every pixel from the network point of view, or every patch, is really effectively another sample. And you can start with 100 samples, sometimes with even less, sometimes with a few tens of samples, if it's a segmentation task. So it depends very much on the task and on the application.
Okay, thank you. So actually, we've finished our time. I'll take the last question, and that's it. I'll say thank you and goodbye. So this is a question by Kevin. I think it's interesting for many of us. What's the best method to manage 2 teams in parallel?
Yeah, so we should ask our team leaders, because 2 teams in parallel is where they start. So there's the role of a team leader in our company is usually it can be managing like 4 teams in parallel, each one with different projects. It starts from recruiting the right people. It starts from building the team to begin with. If you're building a team with people you can trust and people who you are familiar with their skill set, you're going to make it a lot easier. The other thing to take into account is that the team leader or the project manager who's managing multiple teams in parallel needs to learn how to manage themselves, how to manage your own time, how to prioritize your tasks. For me, when I was a team leader, I actually learned this from something very simple called a Kanban board. They have it in Trello or in GitLab issues, GitHub issues. Most people are familiar with this. So we started out by using this to manage the tasks in the software development tasks. And then you've got your backlog and your prioritization and your labels about the classes of tasks. This is a good trading tool, even for sort of personal time management, to understand what you should be thinking about right now, because you have your prioritization and you have your types of tasks and you have your time. Each task should be assigned a deadline, so you know what's a short-term, urgent, and what's less short-term urgent, and to understand what you should be thinking about and what you should be forgetting about, and having the other people on your team who you trust thinking about it.
Great, thank you. Okay, so I think we overcompleted our time, and it's time to say thank you very much for attending this webinar. We hope you find at least most of these tips useful for your own internal development. We'll be happy with your disposal. Please feel free to contact us if you have any question, any matter you would like to consult, or any interesting project that we can maybe assist, in developing for your company. So thank you, Moshe, for joining us today and sharing the data. And I'll be sending you follow-up emails with some material. So until next time, thank you and have a great day.